Hi, good morning. It's a beautiful sunny morning here in Berlin, and apparently I've got nothing better to do than checking out the Azure Machine Learning Studio, which comes with an interactive designer mode that you're going to find here on the left-hand side of the menu once you're in the studio itself. And I was just playing around a little bit with the capabilities, which I found quite interesting. So I've used the Machine Learning Studio in projects myself, where the approach was to commit Python code to Azure DevOps. So Python code would describe all these, the pipelines and experiments that are to be run in the studio. And today I just thought I want to check out the other features, in particular this interactive designer mode, which is quite, it's fairly non-technical. It's no code and non-code, so to speak, and I think it gives you the ability to possibly sketch out, machine learning pipelines end to end, and just play around possibly with some ideas. And so I've done that. I did peek at. They do have examples also up there that kind of give you ideas for as to what you can do with the designer. And so this designer comes with various sample data sets. Each one also has some description along with it. Initially I wanted to check out the German credit default data set, which seemed fairly complicated to get into. So I decided to use the automobile price data instead. Which you see here as a node in my little run graph. I'm sure this can all still be polished, but just you can click on the data node or dataset node. It gives you a broad overview of the table, tabular data, I guess, in here. Price is in this data set the interesting outcome, of course. Various features that describe the automobiles in the dataset. Yeah, so what you can then do is essentially you can just sort of, pull nodes from the left-hand side menu over here into your run graph, and essentially just assemble a machine learning pipeline, which again, no code. There's lots of hidden, I guess, attributes that more technical folks would possibly miss in defining this pipeline. That's a point I want to expand upon in a little bit as well. So essentially, what you can do, I've got this data set up here. As we saw also in the overview, there's some missing values in it, right? In this normalized losses column, for instance. Actually, also notice that there's some missing values in the prices as well. So these are certainly rows that I wouldn't want to train and or then predict on in the test case, because the unknown is not even provided in this row here. So that's certainly something I want to exclude. And so let me do that. So I did add a clean missing data node to my graph, where I said clean. So you can click on edit columns by name or whatever. It even shows you, because we did connect. That's something I haven't explained yet. I mean, I'm just learning as I'm going. Really, I'm just a guy rambling on about something I'm looking at myself right now. So essentially, each node comes with predefined input and output, I guess attributes. And these attributes, they also predefine what you can connect to it. So if I maybe delete this edge right here in the graph, data set output, this is a data frame directory, a type of, location to store data in. And when I select it, to look for a node in this graph to connect this to, the designer already highlights this input attribute of the clean missing data node, because this this tells us the expected type is a data frame directory, just like the output attribute up here. So I'll connect these two guys like that. I guess we didn't actually lose any settings. Right, so what we're doing here is essentially we're filling in these missing values in the normalized losses column with the median sort of selected here in this case. A very rudimentary, there's not even any sort of, hierarchical cleaning mode that I could see right here. Usually I guess you'd want to fill in median values within possibly, automobile make or model classes, because of course a Fiat is going to be is going to have different values in this column, whatever this column is, compared with a Ferrari or something, I'd imagine. Right, so we still want to get rid of the rows in the data set that have missing values in the price column, which is what we want to predict. So let's see, clean missing data. Can we find a drop? I think I saw an example that we can drop missing rows entirely. Maybe that's just another clean missing data node. So the transformation, I guess for later, if you want to train. So for this, you're learning the median here, and if there's new data coming in with potentially also missing values, you want to fill in the missing values with the same median that you used here in your training set. So this is why it makes sense that this is an output node here, this transformation, this median in this case that you learned. So let me fill in, pump, so to speak, speaking of data flow sort of sense, the cleaned rows and data into this node here, and then I'm going to say, let me select price. So this is the column that I want to clean there, and I'll just say remove entire row. So drop all the rows missing value in the price column. So now this is cleaned. So now what I did here is essentially just I want to now train a model on on a training set, on a subset of this data that I've just cleaned. For that, I'll split it. What's the split ratio? So right now it's 50-50, right? First output data set. So the left-hand side output attribute here is data set number 1. It's going to be that. That split is maybe 70-30, right? That's a more traditional train, validate split. Randomized, it's not time series data. So we can just, randomly select rows for training and validation without sort of, feeding any time info into the validation set. Data set being here on the right hand side, data set number 2. And right, so I selected a model, boosted decision tree for regression in this case. I'm going to feed this into into a train model node. Again, pretty self-explanatory. This node has an untrained model output attribute. This one has an untrained model input attribute. So I'm just going to connect these two with an edge. Data set number one is the 70%, the training data that we just defined. That goes into here. That's the data set, right? As we have here. Doesn't always display it. Either way we go. And then there's a score model compute attribute. You can find under model scoring and evaluation. So my understanding, and I haven't even tried running this pipeline, to be honest with you. It's just honestly, I've cheated a bit. I looked at one of the examples, which actually also discusses this automobile price data, and I noticed that they used the score model attribute for evaluating it. And so my understanding is that score model essentially is what you would call predict, right? Or the inference stage. So you've trained your model, and now I'm gonna see, this is the trained model, and now I'm gonna run my model on, predict on, in this case, the validation set, these 30%, the 30% of the data that I left out. Run that. I don't even know. So it's just gonna evaluate it, I suppose. I would hope, given this trained model. I mean, that makes sense for sure. And then I'm gonna feed, the scored data set, which to my mind is then, what in scikit-learn you say, y underscore predicted equals model dot predict on my x test or x validate. So that's, to my understanding, this what this attribute here is, right? And then we're going to feed this into this y predicted into here, this evaluation node. Fill in also, y test or y validate, the original 30% that we had left out from the training. And yeah, so my understanding here is that this evaluation node will then score my prediction against a true, validation set. I don't really see, honestly, exactly what metric is going to compute here, or what score is going to compute here. So yeah, I'm not sure, to be frank here. But yeah, so click submit here. So let me just delete this node here and run the pipeline. Submit it. Yeah, let's do that. So actually, yeah, so something I haven't discussed yet. In this machine learning studio in Azure, when you click submit, what happens is that this graph is sent to a compute instance, which you can define and create yourself, right? So what I have here, yes, this is my test compute, which has to be a unique name in the respective Azure zone. And essentially, this is a virtual machine. My understanding is this is a virtual machine that I create, that I define, right? As I'm sure some operating system runs in a certain, zone. And this virtual machine, my understanding is that it is spun up, when I click submit in the designer. And this is when my code is executed. So it's essentially really just a compute on demand. That's pretty cool. And yeah, that's the example. Let me just go back to this node. So one thing I still wanted to discuss briefly is, so I mean, this is quite nice, I think. It's missing a lot of technical details, of course, I think it's an okay start, right? If you're just starting out, possibly defining some machine learning pipeline, so sketching out some stuff. Where I do see potential really in you're actually using this in an MLOps kind of manner, really sort of defining end-to-end your machine learning project in here and possibly, growing this into an actual, POC, MVP stage kind of product that actually is, even used in some test or even production environment, really sort of delivering value to users or whatever you're trying to do here. So where I see really potential for expanding all this is the fact that you can use apparently Python models in here. All right, I can probably just I cannot edit stuff right now, I suppose, while it's running. But you seem to be able to add custom scripts, right here in the designer, which makes sense. I mean, initially I said, starting in the video, I said, I know Machine Learning Studio from the other way around. So writing Python code and pushing that to DevOps and deploying this in Machine Learning, I guess, Studio or the service anyways. So yeah, for sure you can write Python code and get it into this, display here and have, executed and managed and run here. But you can also come this way, right? Define it interactively and then still add Python code. And my point is here that essentially some of these black boxes or these sort of no code versions of machine learning models, for instance, you can pretty easily replace with your own, scikit-learn, TensorFlow, PyTorch, whatever it is you use, models, while still using these abstractions, for data sets and so forth that Azure, the studio, the machine learning studio provides. So I think you can still, start out here and then, expand on your initial infrastructure and stack in here, right, as you go. And the other thing is that you can also input and output data from and to arbitrary endpoints, so web endpoints. I haven't tried this yet, but this also seems to me that potentially, and I haven't tested this myself, but potentially you could create a inference stage, in production stage machine learning pipeline in here, and then have actual real-time data come in, feed this in potentially, and maybe even cover the inference stage of the machine learning development pipeline in here. I got some failure there. I'm not going to cover this in my video next time though. Just wanted to point out, so actually I'll also start looking at MetaFlow for MLOps. It was originally developed by Netflix. And they also, in this MLOps world that I think it's quite interesting, and we'll be converging on certain standards and ways to do things. The authors of MetaFlow, they proposed this, I think they call it data science infrastructural stack. So the infrastructure required to develop and run machine learning applications, models end to end. And in the stack, top to bottom, they started with the data layer, compute resources, job scheduling, architecture. I'm not sure exactly what they mean by that. All right, okay. I mean, how do you package your code? What is it? How is it structured? Apparently, model versioning and so forth. And so, to my mind, and going into up there, the interesting data science stuff, model development, feature engineering, and so forth. And I think you can see pretty easily that the machine learning studio in Asia covers the same ground, which makes sense. I mean, it's an MLOps, imagine a framework. But I just would like to see the parallels here. So, down there, you're going to have your Azure blob storage as a data warehouse, compute resources. We've looked at that, right? You define your own virtual machine in there. That's, to my understanding, is spun up on demand as your pipeline is submitted for execution. Job scheduler, I've used it extensively. There's scheduling on a time basis and on a data set update basis, I think also. So if a data set is if there's new, you can define data sets which are sort of meta structures on top of where is that, on top of whatever it is, like wherever you store your data, blob storage, for instance. So you can create a data set here and say, these files, following a certain pattern, these CSV files in my blob storage, they, in combination, they are, let's say my weather data, right? Just indexed by time, for instance. So there's a data set, you have that. I was just turning off a little bit, but so yeah, there's different scheduling options built into Machine Learning Studio. Again, this architecture thing I have to read up on, but I also know that you can, then publish your machine learning models, right? Also then versioned and all that. So that's covered. And the studio also certainly it allows you to define what's called, I think, endpoints, right? Which then allows you to use these models that you've built in actual applications and going into this interactive, data science or iterative and interactive data science model development layer of the data science infrastructure stack. The studio also offers notebooks, so you can work on the same data set that you define somewhere here for your pipelines. You can work on those, load them in here. Do your explorative data analysis, do your iterative, model training, and then again, possibly pop into your designer or write these pipelines in Python, and use the same code you develop in the notebooks on the same data set structures that you defined over here. So yeah, I'm just rambling on here, but I thought it was interesting just to even just say it out loud, for even just for myself. I'm not sure anyone's gonna watch this video anyways. Just the parallels, between MetaFlow, this fairly nice and succinct model for a full data science infrastructure stack, how this maps back to a paid service such as Machine Learning Studio in Azure. Which I'm just looking at this because I'm familiar with this from projects that I've done. I guess that's it for now. I'm just was just rambling on here a little bit. That's it, and yeah. Let me know if anyone actually saw this video. And in case you did, what did you think? Have you used the Machine Learning Studio yourself? Have you actually used it in production, building up complex machine learning pipelines deployed into production? And also certainly have you then done the path back, from production? Have you then, have you been able to use Studio to score and evaluate your models that are used out there in the wild against real data? And have you been able to iterate on your models? using Studio. So I'd be keen to learn in case anyone has any insights there. Thanks. Take care. Bye.